All right, so just in terms of today's lesson, there's going to be a lot of notes today. Just going to tell you up front, a lot of writing. So just try to stay with it. I know it's going to be long and like, whew, this is a lot, but this is like our first real lesson in the unit, and that's what happens. Like there's a lot of foundation that needs to be put in place. So just stay with it, okay? Now, what we're going to do is we're going to talk about this form here, right? It's not vertex form, right? Totally different, but it's still quadratic. How do we know it's a quadratic? It's being squared, right? So we should expect, even though it's not vertex form, to still get the same shape that we always get with quadratics, which is that U shape, either a U or an upside down U, right? So that's a good sense check that we can use at the beginning. Like, whatever I end up getting here, it better be a U, because I know these are U's, like, right? Now, we haven't taught you how to graph these in any way other than how you just graph anything, which is to find points, right? So you would make an XY table, right? And you don't know what to choose. A lot of times we go -2 to 2 with our X. I'm going to tell you, let's go -3. Let's go -3 to 3. Expand a little. And then that's going to give us a point at each of these spots if we plug it in, right? So we plug in each of these X's to find our Y, okay? Now plugging it in, well, where do I plug in? Anywhere you see X. So if I see an X here and I see an X here, I'm just going to rewrite the equation but put -3 in that spot instead, right? So what does that look like? Well, to find my first Y, I would say, well, -2, but instead of X, -3 squared minus 4, instead of X, -3 plus 2, right? All I did was replace these X's with -3 in parentheses. Now, you could sit here and be like, all right, -3 squared is 9, 9 times 2. Or you can just grab your calculator and put all of that in and press enter, okay? And if you have a graphing calculator and you put all that in, then when you go to the next one, all you gotta do is press up, go back to everything you typed, and change the number from -3 to -2. Okay? So that's a little trick for graphing calculators. So if you plug all that in, press enter on your calculator, you would get -4. Okay? Then you would go again. You'd say, okay, well now I need to find the next one. So y equals -2 times -2 squared minus 4 times -2 plus 2. Put it in your calculator exactly like that, with the parentheses, squared, and -4 times parentheses -2, and then you won't get the wrong answer. Okay? If you press enter there, you would get 2, right? And you would just repeat that process for all your x values, one at a time, right? And you would get -1, 4, 0, 2, 1, -4, 2, -14, and 3, -28. Now, obviously the numbers got a little big on us here. When we make a table, we're just trying to find possible points. Sometimes the points go off the graph. That's okay, as long as we found other points that we can put on the graph, right? So then we add these points to our graph, -3, -4, -2, 2, -1, 4, 0, 2, 1, -4, and then that's when we got crazy off the graph down there, right? But that's okay. We got enough points before that happened, and we can hopefully see the U shape, right? It's going to be an upside down U, right? Because we had that negative out front, right? And we just need to connect our dots. And there we go. Now, that's our graph. That's doing it the long way. Like, that takes a while to do all those calculations, right? What we would want is a shorter way, right? Well, let's notice some things here, right? Is this thing flipped up or flipped down? Down. What do you think in the equation might have something to do with that?
-2.
Yeah, there's a negative out front, right? Right there. And then the 2 would make it what?
Stretch.
Stretched. Does it look stretched? Yeah, in fact, it goes the way we've learned. It went 1 over 1 down 2, over 2 down 8, right? So this stretch thing and this reflection thing is still in play, even though we're not in vertex form. So really, the one thing that we just don't know by looking at this is the what? The vertex, because we're not in vertex form. So the question we need to answer today is, how do we get the vertex? Right? Because if we can get the vertex, and we know our stretch and we know our flip, we can do the same thing we've been doing, which is using the pattern to get the rest of our points. Okay? So we're going to answer this question. How do we get the vertex when it's in this form? And we're going to talk about what this form is, its pieces, and how you would do that, right? Without having to do an XY table. Okay? So that's where we're going today. Okay? Now, what we need to do is talk about the forms of a quadratic, so we can know what this is. Like, what is this that we're looking at? Because it's not vertex form, so it's got to be something else, right? So we're going to talk about that next, okay? So there are 3 forms of a quadratic. We're going to talk about, I'll introduce you to all 3 today, and then we're going to laser focus on the middle one. Now, the first one, we've talked about already, vertex form. It's like that parent function form where you can see the translations, right? We're going to write it a slightly different way. So it's going to be y equals a times x minus h squared plus k. Okay? So remember, whenever y equals mx plus b, any of these things, there's always a y and an x, and all these other letters that stand for something that you plug into, right? So what do we see here? Well, I got an a, right? I got an h, and I got a k. So those are the 3 letters you would need to know to write in this form, or you would need to pull out of this form, right, to give yourself information. Now we know the A is our what? It's our stretch, and it also tells us about reflection, right? It's our stretch, and it tells us about reflecting if we reflect. Okay? Now our H and our K are our what?
XY.
Yeah, they're the XY of our vertex, right? Good. And that's because you get both of those in this form, this is the really graph-friendly form, right? This is the one where you see everything you need right in the equation, right? So this is graph-friendly. And I'll give you an example for each of these. So let's say you had y equals negative 2 times x plus 3 squared plus 4. Well, our a is negative 2, right? And our hk, or our vertex, would be negative 3, 4. And that tells you everything you need to know to graph it, right? Your vertex is where you would start. You know you would flip down and you would stretch by 2. And you'd use your knowledge of patterns to stretch by 2. Okay? So that's the form we've been dealing with, right? There's 2 other forms. Just like there were different forms of lines, and each form gave you different things. Okay? This next form is called standard form, right? And this is the form that you're going to be working with a lot for the rest of the year. Okay? It looks like this. Y equals ax squared plus bx plus c. So ABC gets put in there, right? We got an A, we got a B, and we got a C. Okay? Now, what do you notice it has that the other one had? A. And there's a reason that letter is used again, because it's the same thing. It's your stretch and your reflection. Right? So A is A. It's the same in both equations, right? It will tell you the same information. Now our B and our C are not. They're new. All right. Excuse me. All right, so we got to talk about our B and our C in this case. Our B is just a number we use in formulas. It doesn't tell you anything about the graph, or at least not in the way that we're going to use it. It's not on the graph. Okay? So you can't look at the B and be like, oh, I know part of the graph. We are going to use it to calculate some things. It does matter, but it's not on the graph. Whereas C is on the graph. Our C is our y-intercept. And see if you can think about it and tell me why our C would be our y-intercept every single time. Think about what a y-intercept is. A y-intercept happens when? When x is 0. Well, I don't even know what A is or what B is, right? But A times 0 squared plus B times 0 plus C. What am I going to be left with? Just C, because this would go away and this would go away. So it doesn't even matter what your A or your B is. If your x is 0, your y will be C, right? So your y-intercept is always 0C. It gives you a point in the graph, right, in the equation, right? So that C value is going to be on your graph every time, okay? For example, if you have y equals 2x squared plus 7x plus 14, right? We know our A value is 2, right? Our B value is 7, and our C value is 14, so our y-intercept is 0, 14. Okay? That's what we can pull from a standard form, just at its surface, right? We're going to do more with this, but that's what you can pull right from the form. Okay? All right, and then the last one, I'm just going to introduce it to you, and we're going to have a whole lesson about it, but there's a third form. It's called intercept form. Y equals A times x minus P times x minus Q. I'm going to zoom in a little here. And again, what do we notice? We got A. And it's A is A is A. It's the same thing. And then we have P and Q. Okay? Our A is our stretch and reflection, as always. And then our P and Q, I highlighted them with the same color because they're related to each other. Well, they are, anybody have a guess? Nope, not our y-intercept, but close. Is that the only axis we got? They're the x-intercepts, right? Think about a parabola, right? Parabolas, if you have a graph, it's too big. Come on. Right? And it goes like this. Well, yeah, it's going to have one y-intercept, right? But can it have two x-intercepts? Right? So this form would give us those two right in the form, right? So for example, and again, we'll have a whole lesson about this. You might have y equals 3 times x minus 2, x minus 8. And your A is 3, so that's your stretch. And then your x-intercepts would be 2, 0, and 8, 0. So that would give you some points on the graph that way, right? So each form gives you a little bit. The first one gives you a lot, the vertex and your stretch. They all give you your stretch. The next one will give you your y-intercept, and it's going to require a little more work to graph. And then the last one gives you your stretch and 2 points for your x-intercepts. Okay? So you get those three forms. Okay, so we're going to work with this one today, standard form. But before we do, we got to make sure we got our terminology in play, and then also we understand why those pieces are important. So you see two words for vocabulary down on the bottom. We're going to come down and we're going to define those, but first we're going to look back at our example so we can identify them in our example. Okay? So you can see an example first before we write a definition. Okay? So, we've dealt with our vertex a little bit now, right? Where's my vertex here? Yep, it's right here, right? This is my vertex. -1, 4. Okay? Now the other word at the bottom in your vocabulary section down there says, it's 3 words. It says axis of symmetry. Right? Axis of symmetry. Well, the word axis, right? We see plenty of axes all the time. There's 2 in front of you right now. What axis? X and Y, right? And think about what they are. They are these kind of imaginary lines that aren't part of your function, but they help guide your function. Yeah?
I'm guessing the axis of symmetry is the axis at which the graph reflects.
Yeah, exactly. It's symmetry tells you things are going to be the same on both sides, and the axis is the line that goes down the middle of your parabola. Okay? So it's just another line that's not part of your graph, but is guiding your graph, right? So in this case, where would my axis be? Yeah, right through -1, right here, right? That would be my axis of symmetry, right? And we could label it. We could say this is our AOS. That's what we use a lot when we're talking about axis of symmetry. We don't have to write the whole thing every time. And guess what? We could write an equation for that. We need to know how to write the equation for a vertical line. How do you do that? Yeah. You do x equals, and then whatever number it goes through on the x-axis. In this case, it's -1. Okay, one more thing to notice before we move to our definitions. What does the axis of symmetry and the vertex have in common? -1, right? I see it here, I see it here. So how can we use that? Well, that means if I know the axis of symmetry, I know the x value of my vertex. If I know the vertex, I know my axis of symmetry, right? So we use those to help find the other sometimes, and we're going to do that today, okay? So let's define these a little bit, these vertex and axis of symmetry. So we'll do that now. Okay, your vertex is the middle starting point of your parabola, right? And it's either the highest point, which we call a max, or your lowest point, which what do you think we call it? A min. So max or min, maximum, minimum points, and we're going to be finding those sometime in this unit, okay? My axis of symmetry is a vertical line that cuts the parabola in half, and I'm going to write perfectly, right? It'll be the same on both sides. The equation for your axis of symmetry, your AOS, will be x equals, well, thinking about our vertex, what do we use? We use that letter h for the x value. So x equals h is your axis of symmetry equation, okay? Same as the vertex. Same x as vertex. Okay? All right, so now what we're going to do is we're going to graph from standard form. I'm going to give you steps, and we're going to do an example as we do the steps, right? We'll do that. I'll teach you one other thing, and then that's the lesson, okay? So take good notes, because these steps are a little confusing at first, so just make sure you're writing it all down, and then when you practice, that's when you'll get good at it, okay? So, graphing in standard form. Okay, so first of all, we got to recognize that it's in standard form, right? Well, we can see, this is in standard form because it's kind of like that y equals ax squared plus bx plus c. So I've seen now that it's in standard form. Now I know I got to use my tools, my steps for graphing in standard form, which I'm about to give you, okay? So, here are your steps. Step 1, find your A, B, and C. So you just got to identify those A, B, and C values, right? Pull them out. We're going to need them all. So looking at our example, what's my A value? What's in the A spot? 3. What's in the B spot? -6. And what's in the C spot? 1. Okay. Now, does anybody remember what a standard form gives us kind of right off the bat? Our y-intercept, right? So we might as well throw that on the graph. That's step 2. Graph your y-intercept. So in this case, our y-intercept is 0, what? 1, right? Because it's our C value. So I can throw that on the graph. Okay? Great. But what was the one thing we said at the very beginning? Like, what's this not give us that we kind of want to know?
Vertex.
Our vertex. All right, the next 2 steps are about finding that vertex. To find the vertex, we first must find, guess?
X or Y.
Well, the x, which we get from our, what has the same x as a vertex? Think about it in the front, what we talked about.
H.
The axis of symmetry. So we're going to find the axis of symmetry. We find our axis of symmetry, and you might say how? Well, there's a formula. Using a formula. Some wonderful person figured out at some point. And that formula is x equals -b over 2 times a. Okay? So this is where we start using our other letters, right? So in our case, our axis of symmetry will be, well, it says -b, so -6, right? So if there's already a negative, you have to go negative, okay? And then over 2 times, our a is what? 3. So -6 is +6. 2 times 3 is 6. 6 over 6 is 1. So our axis of symmetry is x equals 1. And you can grab a highlighter or a dotted line or even a full line. It doesn't really matter as long as it's helping you. And you throw that in right there. Now, we know the vertex falls on the axis of symmetry, right? So it must have the same what value? X value. So now we just need to know the y value. So now we're going to find our vertex. And think about our warm-up, right? When we knew an x and we didn't know a y, what did we do? Like when you know an x, you got a function, you need to find the y, what? Well, you can make a table if you need to find a bunch of points, but if you're just trying to find one, just plug it in. So we plug it in. Plug in x to find y, right? So in our case, it would be, our y would be 3 times 1 squared minus 6 times 1 plus 1. You would definitely want to use your calculator. Make sure you don't make any mistakes, right? Save yourself some time. If you did that, you'd find that it's -2. So our vertex is 1, -2. Right here. Okay, remember we said if we just had our vertex, we'd be in good shape because we know our stretch, we know if it flips, right? So all we got to do to finish this thing, our last step, is add more points. And you can use your axis of symmetry to help, and you can use your stretch to help, right? You can use one, check with the other, right? What do I mean by use the axis of symmetry to help? How could I add a point because I know how the axis of symmetry works?
If you find on one side, you can just flip it.
Yeah, if there's a point on one side, there's a point on the other side. Do you see anything I could add? Yeah, you can add a point right here because there was a point there, so you know there's one on the other side. How could I have used my stretch to find points? I knew my vertex. I knew my stretch was what? 3. So instead of over 1 up 1, I go over 1 up 3, and look, I would have found the same 2 points. Okay? And if I wanted to keep going, well, over 2 up 12 would throw me off the graph, so I know that I have everything I can do here, and I have my parabola. Okay? So those are your steps, right? You need to find your axis of symmetry, plug it in, that'll give you your vertex, and then either use stretch or your knowledge of axis of symmetries to add more points, right? Sometimes both, and then you have your graph and you're done, right? You don't have to make an XY table every time. You need to know this formula and you need to find your axis of symmetry and go from there. Okay? All right, there's one other thing I want to show you before you go, and that is, well, we want to be able to, now that we know 2 forms, we want to be able to go back and forth between the 2 of them. So we want to be able to convert from one to the other algebraically. So I'm going to show you how to convert from vertex form to standard form algebraically. Okay? And then we'll be done. All right. So, ready? Okay, so we're going to convert from vertex to standard, right? So that's going from y equals a times x minus h squared plus k, and then we're going to try to get to y equals ax squared plus bx plus c. And the way I'm going to show you this is I'll show you an example and I'll write the steps on the side as I go through the example. Okay? So here's your example. Let's say you started with y equals -2 times x plus 3 squared plus 4. Okay? And you're trying to get that to be standard form, ax squared plus bx plus c. Right now it's in vertex form. Okay? Your first step, and this is why we practice this in our homework, is you expand your squared parentheses. Okay? You pull them apart. What does that look like? It goes y equals -2, and then instead of x plus 3 squared, I'd put x plus 3 times x plus 3, and then I put plus 4, right? So this became this. You just pulled that apart. That's your first step. Okay? Now my next step is I want to know what x plus 3 times x plus 3 is. So I would box or FOIL my parenthesis binomials now, right? So I have x plus 3 times x plus 3. I got to figure out what that is, and then I'll put that into the equation. So if I did that, I usually want to do it over to the side, right? X plus 3, x plus 3. If I FOILed this, first, outer, inner, last, I would get x squared plus 3x plus 3x plus 9, which would become x squared plus 6x plus 9, right? So that means x plus 3 times x plus 3 is the same as this, right? This becomes this. So this gets plugged into the equation in that spot right here, right? If this became this, then it can be plugged in that spot. So that's what I do, right? And I end up with y equals -2 times x squared plus 6x plus 9, and then plus 4 at the end. Okay?
Do you have to put the parentheses?
Yes, because now I'm going to distribute. And I need to make sure I distribute to everything, right? Because my next step is distribute your a value, that number out front, okay? So this a value needs to go get distributed through, and that's why I put it in parentheses to make sure I do that, okay? So what happens? Well, we end up with y equals -2x squared minus 12x minus 18, and then again, I still have this plus 4 at the end. And the only thing I have to do now is what? Simplify. -18 plus 4 can be combined. So the last step is combine your numbers, your like terms. In this case, it's these two, right? So I have y equals -2x squared minus 12x minus 14. And I have now converted this to standard form from vertex form.
So we're gonna have to know how to do it backwards to put it from standard form to vertex form.
Eventually. That's a little harder. Let's worry about just doing it this way today. But yeah, we're going to do something called completing the square. Okay? So today on your homework, you're going to practice graphing in standard form and converting like this.